Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. So let's carry on with some more interesting problems on Jacobians. See the question here. This question is very important and it has been asked several times in a VTU examination for around 7 marks. So it says if u is equal to yz by x, v is equal to zx by y and w is equal to xy by z, show that dou of u w upon dou of xyz is equal to 4. That is the Jacobian is equal to 4. Okay, so let's solve this now. So as we have discussed in the previous videos about Jacobians and solve a couple of problems also. So if you haven't, then please check the link in the description below and watch the video. Okay, now coming to this problem, so we have dou of u v w upon dou of x y z will be the determinant. So tell me what now? First, u with respect to all x, y, z. So we have dou u by dou x, dou u by dou y and dou u by dou z. Next, v with respect to all. So dou v by dou x, dou v by dou y and dou v by dou z. Lastly, w with respect to all, dou w by dou x, dou w by dou y, dou w by dou z. That's it. Now, let's fill this determinant with all the partial derivatives. Okay. So, now here we have to partially differentiate all these terms. So, first, listen carefully what I say. See, these videos are more than enough to pass the VTU exams and secure great marks. So please watch till the end without skipping so that you get the full benefit and do a great day today. Share this video to as many as friends as possible. Let's help everyone succeed together. Okay, now coming back to the solution here. Dou u by dou x. Again, listen carefully, lend the ears to me. My words are designed to enter your brain, fit in your brain. Okay. Now see, dou u by dou x. We have u is equal to yz by x. Here we are partially differentiating dou u by dou x. U with respect to x. X is down here. X is where? Down. See, x is down. So yz will be as it is. What? Yz as it is upon, we are differentiating yz, don't touch it, as it is upon x. So we are differentiating only 1 by x, and as I keep on repeating, the very important derivative in engineering, it is differentiation of 1 by x is how much? Minus 1 by x square, minus 1 by x square. So dou u by dou x is yz as it is into 1 by x, differentiation 1 by x is minus 1 by x square. That's it. Dou u by dou y, again see here, y stop here. So, in the numerator, so z by x as it is, differentiation y is 1, that's it. Next, dou u by dou z, again here z stop here, see here, z stop in the numerator. So, y by x as it is, differentiation of z is 1, since it is in the numerator, that's it. Got it clearly? Next, dou v by dou x, see here, v is zx by y. X is in the numerator. So z by y, don't touch it, as it is. Differentiation of x is 1. That's it. Dou v by dou y. Here again see zx as it is. Y is down here in the denominator. Zx as it is, you are partially differentiating with respect to y. V with respect to y. So zx, don't touch it, as it is. Into is there. Into differentiate 1 by y is what again? With respect to y, minus 1 by y square. Minus 1 by y square, and dou v by dou z, here z is here in the numerator, x by y as it is, differentiation of z is 1. Lastly, dou w by dou x, what is w? X y by z. Dou w by dou x means you are differentiating w with respect to only x. So x in the numerator, y by z as it is, differentiation x is what? 1. Dou w by dou y. See, y, x by z as it is, y is in the numerator. So, z by x by z as it is, differentiation y is 1. Lastly, dou w by dou z, x y as it is again, we are differentiating partially with respect to what? Z here. That means we have y x y as it is, dou w by dou z into partial differentiation of 1 by z is nothing but minus 1 by z square with respect to z. So, minus 1 by z square. Beautiful. So, we have this determinant here, the Jacobian with all the partial derivatives. Now, let us solve this, and to solve this will be what? Plus, minus and plus always. Okay. So, let us solve this in a very easy way now. Even if you are forgot determinant, I show you how to solve it. Fine. Now, first we are taking this term first, minus, that is equal to minus yz by x square into, when I take this first term, sign is plus. Okay. So, there is minus here. So, I took a minus, a plus and minus is minus. Fine. This column, leave it and leave this row. Which the element you are taking, leave that column and leave the row. What remains? This into this minus this into this. Agreed? Multiply. So, we get minus into minus plus. We get z x square y upon z square y square minus this in this x into x square by y z. Okay. So, next is minus, see the sign here is minus, minus the element is z by x into, so I am taking z by x, that column leave it and that row you leave it, getting. So, I leave this column and this row associated with the element. So, when I do that, it will be now this into this minus this into this. So, minus x y z divided by z square y minus this x y divided by y z. That is it. Lastly, this element plus, sign is plus, plus y by x into, now when I take this element, then definitely you are going to leave this column and this row. What remains? This into this minus this into this. That is it. So, x into z is xz divided by yz minus this. See, minus sign is here. So, minus to minus becomes plus zxy divided by y square z. Okay, done. Now, we need to simplify and get the result here. We need to get the result as 4. Okay, let us do it step by step. I hope you got up to here. Again, please lend your ears what I am doing. See, simplification. So, this will be minus yz by x square into, here z, 1 z cancels, y, 1 y cancels. What remains? In the numerator, x square divided by zy minus x square by, again this is yz or zy, both are same, minus z by x into, again here y and y cancels, 1 z and 1 z cancels. So, what remains is x by z minus x by z minus, again here see again y and y cancels off. We get x by z. I am doing each and every step here. So, practice along with me. You will be benefited from this. Okay. So, plus y by x into, again tell me what, z and z cancels here. So, x by y, and here similarly see here z and z cancels, y and y cancels. What remains? X by y. So, plus x by y. Done. Understood? Next, again let us simplify this. So, here this whole thing x square by zy minus x square by zy cancels. So, what remains? Minus z by x into, see, minus x by z is minus 2x by z. Fine. Then again here plus y by x into x by y plus x by y is 2x by y. Beautiful. So, again see x cancels, z cancels, y cancels, x cancels. Minus into minus is what? It's plus 2. So, we have here plus 2 plus x cancel plus 2. So, what is 2 plus 2? Is nothing but 4. That is the answer. So, we have proved that for this question, we have proved that dou u v w by dou x y z, that is Jacobian, is nothing but equal to how much? 4. That is a beautiful solution and a compulsory asked question in the examination. So, please practice it so that you become perfect. So, let us solve the next very interesting question here. It says if x plus y plus z is equal to u, comma y plus z is equal to v and z is equal to u v w, find the value of dou x y z by dou u v w. That is Jacobian of x y z with respect to u v w. A little different question here. In the previous questions problems which are solved, we were supposed to find dou u v w by dou x y z where u v w were the variables and functions of x y z, and but here x y z are the variables and u v w are the functions. So, let us write the Jacobian here. So, we have implies dou of x y z with respect to dou of u v w is equal to, we have here x with respect to all u v w, x with respect to all. So, that is what? Dou x by dou u, then dou x by dou v and dou x by dou w. Next, y with respect to all, the partial derivative of y with respect to all u v w, dou y by dou u, dou y by dou v and dou y by dou w. Understood? Lastly, z with respect to all u v w, dou z by dou u, dou z by dou v and dou z by dou w. This is what we have, the determinant. Okay. Now, let us solve this, but the problem here is, if you see the question, they given x plus y plus z is equal to u, y plus z is equal to v and z is equal to u v w, but the partial derivatives inside the determinant which we are required to find are dou x by dou u, dou x by dou v, dou x by dou u, dou y by dou v, dou z by dou u, so on. It means to solve this partial derivatives, I need x in functions of u v w, y in functions of u v w and z in as a function of u v w. What? We need x in terms of u v w, y in terms of u v w and z in terms of u v w. Z, no issue, is already there, but we need to play with these three equations to find a solution such that I get x in terms of u v w, y in terms of u v w and z in terms of u v w to get this partial derivatives. Getting it? So, I write here one more time. So, we have x plus y plus z is equal to u, right? Then y plus z is equal to v and z is equal to u v w. Okay. Now, see here, if you see here carefully, y plus z is equal to what? V. I will put here. Getting it? So if you put here y plus z is what? V. So x plus v is equal to u. Correct? That means x is equal to u minus v. I have this. So I have found x in terms of u. Fine. Next, again, see here. We have z is equal to uv, y plus z is equal to v. So here I can put z is equal to what? uv. So again, y plus uvw is equal to v. So y is equal to v minus uvw. Now, beautiful, I have y also in terms of uvw, but z is already given in terms of uvw. There is no need to again do anything for it. So I have these three expressions here. What I require, I have x in terms of uvw, I have y in terms of uvw, and z in terms of uvw. So I can directly fill up this determinant. So I write here itself. So this will be now dou x by dou u. What is x? U minus v. Simple. Dou x by dou u, partial differentiation of x with respect to u. U, differentiation of u is 1. That's it. Dou x by dou v, u, constant 0. Differentiation of u is 1. This is minus sign here, don't forget it. Differentiation of minus v is minus 1. Lastly, dou x by dou w, x is u minus v, there is no w here, both are constant. So differential constant is what? 0. That's it. Next, dou y by dou u, dou y by what? Dou u. See, what is y? Y is v minus tvw. We need to partially differentiate y with respect to what? U. U is only here, v is 0. So vw minus vw as it is, differential u is 1. Getting it? See, dou y by dou u, v constant 0. You need to differentiate partially only with respect to u. U is here, vw as it is, differential u is 1, and there is a minus sign here. So minus what? vw. Okay. Next, dou y by dou v. V we are differentiating partially, y with respect to v. See, v 1 minus uw as it is, differential of v is what? 1. Getting it clear? Dou y by dou w, v is 0 minus uv as it is, v as it is, differentiation of w is 1. We are differentiating dou y by dou w means we are partially differentiating y with respect to w. So v is constant 0, only w terms is multiplied, uv as it is minus uv as it is, don't touch it, differential w is 1. That's clear. So better take a notebook, take a pen, and keep on practicing with me. Okay, that will fit in your brain perfectly, because this question is very, very important. The next one, dou z by dou u. Very simple. UVW, dou z by dou u, VW as it is. What? VW as it is, differential u is 1. Dou z by dou v, partial differential z with respect to v. So UW as it is, partial differentiation of v is 1. Dou z by dou w with respect to w, uv as it is, and partial differentiation of w is with z with respect to w is 1. That's it. So if we have finished up filling this determinant by the partial derivatives, okay. So what we did here? We needed x with respect to u, x with v, y with u, y with v, z with v, z with v, so on. So the question was little tricky. So what we did? Using the question, we played with the question and we found all x, y, z in terms of UVW, so that you can find the partial derivatives given in the determinant. We found it here as x is equal to u minus v, y is equal to v minus UVW, and z is equal to UVW, and we filled the determinants of the Jacobian. Now let's solve this. Okay, so this will be plus, minus, plus again. I'll solve each and every step here. Now this is equal to, so let's solve this determinant here. See, before solving, your support keeps me motivated to create more helpful videos even I am fighting to the stage of cancer. So every click truly matters. So please hit the subscribe button and hit the bell icon so that you remain updated on the series for the VTU for Engineering Maths 1, 2, 3 and 4. Fine. So, moving on to the solution here. So, we have plus 1 into bracket. Again, I am solving each and every step here. So, listen carefully, pay attention here and better practice it in your notebooks. So, plus 1 into, see, when I take this first element 1, I leave this column containing that element and the row containing that element, row and column leave it. So, what remains is this into this minus this into this. Okay, so let us multiply it. So, we have uv into 1 minus uw minus this into this into this minus uv into uw. So, minus into minus becomes what? Plus. Getting it clear? So, this into this minus of minus plus u square v w minus the element is minus 1. So, minus into minus. If it was only plain 1, then obviously take minus sign, but here this element is also minus here, the plus minus plus. Minus into minus is what? Plus, don't miss it. Plus 1 into again. So, what is the case here now? We leave this, we take this element minus 1, we leave this column and we leave this row associated with that. That means what remains? This into this minus this into this. So, we have u minus vw into uv is minus u v square w. Again this into this minus of again minus becomes plus minus uv into vw minus uv plus. So, u v square w, that is all. Finally, lastly plus 0 into anything is 0, that is it. So, let us simplify here now. So, we have 1 into uv minus u v square w plus u v square w, and this obviously cancels. U v square w plus u v square w is 0, and here also u v square w plus u v square w is what? 0. That means we have this as 1 into uv is nothing but uv. That is the answer. Understood? Therefore, that implies dou of x, y, z with respect to uvw is equal to how much? uv. That is the answer. That is it. Beautiful solution and compulsory ask question in the examination. So, only one thing, you need to practice to get it perfectly. So, that is all for today, friends. I hope you understood how to solve the Jacobians in a very, very easy way. Obviously, you might be knowing it earlier, but now it has become more perfect and fitted in your brains. Okay, but the main ingredient for success and getting full marks is practice. So, obviously, these videos are free. Watch them how many times you want, refer them, take a notebook, take a pen, practice how many times you want so that it becomes perfect and don't lose any marks in the examination. And please don't forget to share this video with the friends so that they also can get benefited. Till then, keep practicing, be confident, happy engineering. Bye.